Just when you thought you were all done with geometry? Psych! Guess again. We got one more video, fools. And this is going to be some stuff you will definitely do next year in Algebra 2, so this is definitely worth your time and effort to do this stuff here. So this will be a nice bridge between this year and next year. Now, here's the thing. You might notice, hey, I didn't get any notes from Mr. G for this section. It's because you're going to take your own notes. There's not going to be a lot, so don't worry. And don't write everything down, but write down just the main important pieces. Okay, be very precise with your own notes here. I'm not going to check them, but you will definitely probably find these notes useful for next year. So, there's this concept called completing the square. Okay, and maybe you've done this in Algebra 1, but more than likely you didn't cover it. And you might ask, why would I want to do this concept called completing the square? Well, in addition to factoring and the quadratic formula for solving a trinomial, there's this idea called completing the square. Okay, and it's kind of a combination of both things. It can be used really as a shortcut to the quadratic formula, which is nice because who wants to remember that big, ugly, long, nasty thing and plug all those values in and then simplify that atrocious fraction of the quadratic formula when you could potentially do completing the square. Now, completing the square really isn't that hard of a topic to do here, but I'm going to kind of take you through the steps here of what it looks like and how it works. So let's say this is what you would want to try to factor, and you look at this and you go, I mean, I need two numbers that multiply to be -4 but add to be +8. There are no such numbers, so this thing won't factor, which means, oh man, now we got to use the quadratic formula. But again, here is an alternative with completing the square. The first thing you're going to want to do is to move the constant, or the number that doesn't have the x, to the other side of the equal sign. So notice this was originally a -4. We added 4 to the other side so that we now have this. So all of our x stuff is on one side of the equal sign. It doesn't have to be the left, but typically that's where you'll see it, is on the left side. So now notice I put a little plus in a box, and I put the same box over here. We need to figure out a value that we're going to really add to both sides to maintain equality here. But here's how we're going to get that specific number. Okay? This is where step 4 is going to come into play. Whatever this value is that's with the x term, in this case +8, you're always going to do this. You're going to take half of that number and square it. So half of 8 is 4, and then we need to square it, which is 16. And that number is the number that you are technically going to add to both sides of your equation to maintain equality. So now we've got x squared plus 8x plus 16 equals, and really 4 plus 16 over here makes that 20. So you can go ahead and add that together. That's fine. Okay? Now, this part over here, the reason why it's called completing the square is because this will now factor into a perfect square. Okay? And really whatever this number is right here is whatever the take half part was. And half of that 8 was 4. So if you think about it, if you took x plus 4 and squared it, which means times another x plus 4, you distribute here and you're going to have x squared plus 4x. Distribute the 4 and you'll have another 4x plus 16. Your 4x and 4x make your 8x, and your 16, there it is. So this is the whole idea behind completing the square, is that you want to create some number, because the way we originally had it here with this -4, it wouldn't make a perfect square trinomial, is what this is referred to, a perfect square trinomial. So it wouldn't make it that. So we can make it that by figuring out what number we'd really need to belong there. But in order to counterbalance that, you need to add that same amount, again, to the other side of the equation. Okay? So at this point, you've got x plus 4 squared equals this 20. That's as far as I really want you to go with it for now. You could end up solving this thing, and this is where the quadratic formula part starts to take fruition, is to get rid of the square. And again, you're not going to have to do this, but let me again tie in the quadratic formula into this. We could square root both sides. Now, whenever you impose a square root, technically you have to take the positive and the negative version of it. Okay? So now, with that square and square root canceling out, we have x plus 4 equals plus or minus the square root of 20. So let's take that which we have here, or really I subtracted the 4 over, so now I have x equals negative 4 plus or minus root 20. The square root of 20 simplifies to be 2 root 5, and so now we can split up the plus and minus into the plus and the minus part, and if you were to use the quadratic formula, this is what it would simplify to be as your final answer, okay, which is kind of nice. So you get to avoid that whole mess of the quadratic formula using the completing the square process, okay? So let's look at another example. So we have x squared plus 6x plus 1. This will definitely not factor, okay? What two numbers multiply to be 1? 1 and 1. But does 1 and 1 add to be 6? No way. So again, we want to take this 1 and we want to move it over to the other side. So we move it over to the other side and now it's a negative 1. So now we want to introduce kind of spacing here. So now we're going to take half of our 6, because that's the number with our x term. We want to take half of the 6, which is 3, and then square that to get 9. So that is the number that we're going to add to both sides of our equation. All right? So now we've got that, and this is going to turn into the 8 here. So now all we need to do is factor the x squared plus 6x plus 9, which is going to turn into our perfect square trinomial. And what number needs to go after the plus in this case? Again, whatever half of that b term was, if you would, which is your 3. So then this would be x plus 3 quantity squared equals 8. And again, we could solve it, but we're not going to be shooting for the solving part. Okay? So this is, again, the quadratic formula. Kind of speed it up here, if you will. So now, how does all this completing the square, anything related to what we've been doing with circles? Okay, so this was standard form for circles in the last video. If I were to take all this and just go to town on it, like, all right, well, let's expand out what these things mean. Okay, well, x minus 2 quantity squared is really this. Y plus 5 quantity squared is really this. All right, let's combine like terms. So really the only like terms you would have would really be your plus 4 and your plus 25. Now, the whole goal is to take all this and to make it look more like this, which is general form for a circle, where it's x squared plus y squared, and then maybe we have an x term, maybe a y squared, and then a constant, and then equals 0. Okay, so all we really did was we took this and we moved it over here, and then we took our x term, we moved it there, and our y term, and then our 4 and 25 together made 29, but once we subtract this 9 over, then there's how I got that 20. So the 20 is really the E, the 10 is the D, the negative 4 is the C in that case. Okay? Now, what we're going to do more is the backwards process of this. We're going to take the general form and rewrite it in standard form. And you might ask, well, why would we even care to do that? Well, think about this. If I gave you just this, and I said, hey, where's the center of this circle located? What is the radius of this circle? In this form, you really have no clue where that's located. You would need to see it more in the standard form, which would be this. And then you'd go, oh, at 2 comma negative 5, and with a radius of 3, that's what the circle would be. Okay, so now let's do some backwards problems here. So let's convert this general form of the equation of a circle into the center radius form, aka standard form. Now, here's the thing. We're going to have to do completing the square twice. Once for the x's, and then once again for the y's. Okay? Now, I like the way this problem, I just pulled this off some website, how they color-coded everything here. So they took this and they took the x terms, which are these two guys, and they said, all right, let's put them by each other. Okay? Let's rearrange some terms here. And then let's take our y stuff, the y squared and the minus 6y, and let's move them together. And then they took that plus 8 and they said, you know what? It's not an x or y, so let's move it over to the other side. Let's make it now minus 8 over here. So now we're just going to do completing the square twice. Okay? So when we look at our x part over here, we need to take half of this negative 4, and half of negative 4 is negative 2, and we need to square negative 2. So negative 2 times itself would be 4. So they put 4 here, and they added 4 to the other side to maintain balance, algebraic equality here. And then they did the same thing with the y's. They said, all right, let's take half of this -6, which is -3, square it, and it's 9. So they added 9 to this side, added 9 to that side. Okay, so now this part turns into x minus 2 quantity squared, because remember, whatever half of this was, which was -2, that's technically what we're going to write there. And then they took the y part, and again, half of -6, -3, that's why that goes there. And then they took all of this, the -8 we originally had, the 4 from the x's, and the 9 from the y's, and they added these three numbers together to get to 5. Okay, so now if you look at this, you know the center is at 2, 3, and you know that the radius is the square root of 5. Okay? So now, what I want you guys to do is do this one on your own. Convert this to standard form. So write this down, bring it to class tomorrow, and we will go over it together to make sure you're on the right page. And you will have completed the square, really twice, once for x and one for y. That is all. Good luck, goodbye, and that is all the videos for the last time of the year.